Questions 21 through 25 on the 2012 Grade 10 AMC 10B. 4 distinct points are arranged in a plane so that segments connecting them have lengths A, 2A, and B. What is the ratio of B to A? The fact that one of the answer choices is pi should alert you to a certain fact, that there's a circle involved. It may not, but perhaps it could. So that is how we have to distribute these points. And I will explain how. So let's say one point is here in the center, and I'll call that A. The next point, there's only 4 points, so A, B, C, and D. The next point, B, is right here. The next point, C, I will place right here. And then D I will put here. And this will all match because the segments are really AB, AC, AD, BC, BD, and finally CD. So A to B is A. They've given us that, so I'll just label it A. And A, of course, is the radius of the circle. A to C is also the radius of the circle, and it makes perfect sense that that is also A. A to D, again, radius of the circle is also A, so that takes care of the first 3. The next one is BC. Now that, they're saying is also A. Okay, no problem. That basically makes this a equilateral triangle. And then the next one, BD, is 2A. And that is the diameter of the circle. So 2A makes perfect sense. And now they're saying finally CD is B. So from C to D is B. And they want you to figure out the ratio of B to A. So they want you to find B over A. What does that equal? Okay. Well, the heart of this question obviously will be this triangle right here. This triangle will help us figure out the ratio between A and B. Now immediately you can tell that it's an isosceles triangle, and if I draw a perpendicular from A down to the other side, where that is a right angle, that will help me to figure out a relationship between A and B. Now remember that this triangle was equilateral. So that means all the angles are 60. So that's 60, and so on, right? Well, if this is 60, then that means from here to here must be 120. From here to here is 120 degrees. And this line will chop that angle in half, so making it 60 and 60, like that. And this is 90, since that was a perpendicular, so therefore this is 30. So there we go. We've got a 30, 60, 90 triangle. And I will just draw that triangle on the side here, just to avoid making the diagram messy. And what we have is a right angle here, 60 degrees here, 30 degrees. And labeling this side is of course A. And from here to here, be careful, the full length was B. So just from here to here is B over 2. Now the ratio of the sides of any 30, 60, 90 triangle are 1, root 3, and 2. So using those ratios, we can figure out the relationship between B and A. B over A. In this case, we can use our sides. Well, we have B over 2, so that's fine. We can just put B over 2 over A for now. And that's going to be the equivalent of root 3 over 2. Cross multiply, and you get B is equal to root 3A. And then bring the A back down, and you get B over A is just root 3. So number 21, the answer is A. Let A1, A2, ... until A10 be a list of the first 10 positive integers such that for each I between 2 and 10 inclusive, either AI plus 1 or AI minus 1, or both appear somewhere before AI in the list. How many such lists are there? Well, they're saying that this is the first 10 positive integers. So that means that must be these numbers in some order, not necessarily in this order, but these 10 numbers have to be A1 through A10 in some order. All lists have to have these 10 numbers, the first 10 positive integers. Now we have to figure out a way of arranging this. If you analyze this question carefully, if you understand it, you will basically see that whenever you take a number, for example, let's say that number is 3, and that is our AI. Then they're saying AI plus 1 or AI minus 1, which in this case would be either 4 or 2, both, either or both, appear somewhere before the 3. So that means in this list, the 2 would appear before the 3, or the 4 would appear before the 3, or both appear before the 3, right? Either this one or both. So we just have to figure out all the arrangements. So let's start with the first number being a 1. If the first number is a 1, then that means all the other numbers have to be between 2 and 10. And really, there's only one way of doing that, which is making them the same way that you have up here. So in brackets, I'll just put how many possible ways of doing that. There's only one way of doing that. If the first number is a 2, then I've got to make sure that somewhere in the next 9 numbers, I've got to put a 1. Because if this is 2, then obviously that has to appear before the 1. And the 1 can go anywhere. So of the 9 possible places, I have to choose 1. So 9 choose 1 is the way of figuring that out. And that is equal to 9. And then if the first number is 3, in the next 9 numbers, I've got to place the 1 and the 2. And the 1 and the 2, out of the 9 possibilities, I've got to choose 2 places for the 1 and 2 for those numbers. And 9 choose 2 is equal to 36. If the first number is 4, in a very similar way, in the remaining 9 numbers, I've got to place the 1, 2, and 3. And from 9, therefore, I've got to choose 3 slots for those 3 numbers. And that's 84. And then you just keep doing this. So when it's all said and done, the total would basically be this 1 up here, plus 9 choose 1, plus 9 choose 2, all the way up until the very last one, which is 9 choose 9. And that is 1 plus 9 plus 36 plus 84 plus 126 plus 126 plus 84 plus 36 plus 9 and plus 1. So the good news about these is that they kind of rise and fall in the same way. It saves a little bit of time. And when you add it all up, it's 512. So 512 is the answer to number 22, and that makes it choice B. A solid tetrahedron is sliced off a solid wooden unit cube by a plane passing through 2 non-adjacent vertices on one face and 1 vertex on the opposite face, not adjacent to either of the first two vertices. The tetrahedron is discarded and the remaining portion of the cube is placed on a table. With the cut surface face down, what is the height of this object? So here is our cube, and first we have to choose the vertices. So I'll choose this one, this vertice, and this vertice according to the rules of the question. And then I'll draw the slice that will be used to cut that cube. And there it is. So that red represents the plane that cuts that cube into a tetrahedron, and then a remaining piece. Now, what am I being asked in this question? I'm being asked to find the height. So when you cut this and discard it, the height will be from one end to the other. So we are going to calculate it like that. So for example, if I draw a line from one end to the other, that represents obviously the full diagonal. But if I subtract from that full diagonal the height of the tetrahedron, it will give me the height of that other piece. So really what I'm asking, or being asked, is the height of that shape. So I'll just call it HS. It is really the diagonal that I've drawn in blue minus the height of the tetrahedron. Now the height of the diagonal is pretty easy to find. We can use just a couple Pythagorean theorems. The first one is this one. They tell me that it is a unit cube, so each side is 1. So this is 1, this is 1. Very quickly you can figure out that's root 2. And then this is 1. So if this blue line is the diagonal squared is equal to 1 squared plus root 2 squared. So it's 1 plus 2 is d squared, and therefore d is equal to root 3. So very quickly, that's root 3. If I can get the height of the tetrahedron, I'm set. Well, first of all, what is the volume of a tetrahedron? It's 1/3 times the area of the base times the height. And in this tetrahedron, we can look at it in two different ways. And in both ways, we can figure out the volume, and then we can equate them. So the first way is when you treat this as the base, right there, and you treat this as the height. That makes it very simple. This is 1, this is 1, and this is 1. So it becomes 1/3 the base, which is just a 1/2 times base times height, and then the height is 1. So in a very easy way, we can figure out that this is 1/6. That is the volume of the tetrahedron. Another way to figure out the volume of that same tetrahedron is to use this as the base. That plane is going to be used as the base. And then the height will be this guy, this HT. That is very important to me. So I'll put that HT right there. So all I need to do is figure out this base now, because this volume is 1/6. I just figured that out over here. It's the same tetrahedron. Now how do I figure out the area of that base? Well, it will be kind of helpful if I draw it out. But the good news is that this is a cube with all the same sides. So very quickly I can figure out the sides of that red triangular base. From here to here, well, that's just root 2, right? You can figure out that because it's going to be root 2 from Pythagoras. In a very similar way, that is also root 2. And in a very similar way, that is also root 2. So when it's drawn in a slant like that, it doesn't look like equilateral, but it actually is an equilateral triangle. So here we go. We'll draw that equilateral triangle like that. And we can figure out the area of that equilateral triangle very easily. All the sides are root 2, root 2, root 2, like that. And when I chop it in half, this of course will be root 2 over 2. This is once again a 30, 60, 90 triangle. And I can figure out the height of that pretty easily. Height over root 2 over 2. And 30, 60, 90 triangle, the ratio is root 3 over 1. So h becomes root 6 over 2. All right. Plug that back into here now. The area of this base is 1/2 base, which is root 2, times height, which we just figured out was root 6 over 2. So this becomes 1/6 is equal to root 12 over 12. And don't forget that HT. All right. So now we just have to do a little bit of algebra. And if you isolate for HT, you will get 2 over root 12. And there we go. That's the last piece of the puzzle we needed to figure out our HS, which is the height of that object. So minus 2 over root 12. Root 3 minus 2 over root 12. And that is the answer, but it's not in the form that they want it. No problem. We can just do the algebra here. Root 3, top and bottom, by root 12 to rationalize that denominator. And that becomes root 3 minus 2. Root 12 is what? 2 root 3. So 2 root 3. And then that's over just 12. So that means you've got root 3 minus 4 root 3 over 12. This reduces to root 3 over 3. And then finally we just add the fraction. 3 root 3 minus root 3 is 2 root 3 over 3. And there you go. 2 root 3 over 3. And number 23, therefore, the answer is D. Amy, Beth, and Joe listen to 4 different songs and discuss which ones they like. No song is liked by all 3. Furthermore, for each of the 3 pairs of the girls, there is at least one song liked by 2 girls, but disliked by the 3rd. How many different ways is this possible? So let's talk about this first before we dive right into the solution. There's 3 girls. There's Amy, there's Beth, and there's Joe. Now, there's 4 songs. I'll call them S1, S2, S3, and S4. Now, we have to make a scenario that matches the criteria in the question. No song is liked by all 3. Okay? So, song 1, let's say, is liked by A and Joe. So that means it's disliked by B. And for dislike, I'll put a red. Similarly, we can just put, S2s and S3s and like that everywhere. So anyway you'd like, say S2 is here, S3 is liked by those 2, and S4 say is liked by those 2. And then of course we have to put in the fact that it was disliked by the other girl. So this is one scenario that is fitting the question, right? That they listen to 4 songs and no song is liked by all 3. So as you can see, no song has 3 colored in blue. And now we have to talk about the second part of the question, which is the pairs of the girls. So what pairs are there? There's AB, there's AJ, and then there's B and Joe, right? Those 3 pairs, there's at least one song liked by those 2 girls, but disliked by the 3rd. Okay, so let's talk about that. For AB, which is the song that both of them like? Well, A and B both like S3. S3 was the one that both of them liked. And was it disliked by Joe? Yes, it was. So as you can see, that matches. It's right here. A and Joe, which song was liked by both of them? S4. Well, S1 also. Well, it doesn't really matter. I'm just trying to explain this. So S1 was liked by both, and S1 was not liked by the other party, which in that case was B. And then B and Joe, which ones do they like? The way I wrote it, S2 is the one they like. And A disliked S2. So the point I'm trying to make with this example, that's one possible way of doing it. They're saying how many different ways are possible? All right, well, that's going to be a little bit more complicated than just one scenario. So here is the explanation. Each song is liked by 2 of the girls, correct? Then one of the 3 pairs of girls likes one of the 6 possible pairs of songs. So for example, A and Joe like S1 and S4. One of the remaining pairs likes one of the remaining two songs. So that, let's say B and Joe, they like S2. And the last pair likes the last song. So the last pair is A and B, and they like S3. So what they're saying is that that all can happen in the following ways. 3 times 6 times 2. And I believe how they got that is 3 pairs of girls, 6 possible pairs of songs, and you've got, of course, 2 songs. So for example, let's explain this. You've got each song is liked by 2 of the girls, right? As you can clearly see, that's the case right up here in my little example. And then each of the 3 pairs of girls likes one of the 6 possible pairs of songs. So our pairs are AB, AJ, and BJ. And the 6 possible pairs of songs are S1, S2, S1, S3, S1, S4, S2, S3, S2, S4, and finally S3, S4. So in our case, we have A and J, let's say, likes one of the 6 possible pairs of songs, and our pair for A and J is S1 and S4. And one of the remaining pairs of girls, so for example AB, likes one of the other 2 songs. So AB likes S2, S3, just S3. And then there's one song left, and that obviously belongs to the other pair, which is BJ. And BJ likes, obviously, the one song that's remaining, which is S2. So the 3 that they have here comes from here, 3 possible choices. The 6 comes from this, and the 2 comes from the fact that once this is selected, you got 2 choices remaining for here. It could be either S3 or S2 in my example. And then the last one for BJ is just going to be the very last song by default. So that's how they get 36. Okay, I hope that was explained well. Now let's look at the other case. 3 songs are each liked by a different pair of girls, and the 4th song is liked by at most 1 girl. There are 4 factorial, which is 24 ways to assign these songs to these 4 categories, and the last song can be liked by Amy, Beth, Joe, or no one. This can occur in 24 times 4, which is 96 ways. So one song is liked by AB, one song is liked by BJ, and one song is also liked by AJ. So for the first pair of girls, there's 4 possible songs that they could like. S1, S2, S3, or S4. So there's 4 possible. Now the next group, BJ, they can like any of the remaining 3. Either, if AB liked S1, BJ can write like S2, S3, or S4. So there's 3 possible choices. For AJ, they've got only 2 possible choices. Now at that point, there's 1 song left. And that one remaining song can be liked by an individual girl, either A, B, or J, or by nobody. So there's 4 possible ways of that last song being allocated. So that's why you put a 4 there. And this is the total number of cases in the second scenario. And that totals 96. So you have to add the 36 with the 96. And when you do, you get 132 total number of possibilities. And therefore, this question number 24, the answer is B. A bug travels from A to B along the segments in the hexagonal lattice pictured below. The segments marked with an arrow can be traveled only in the direction of the arrow, and the bug never travels the same segment more than once. How many different paths are there? Well, this is a rather challenging question. This diagram colors the paths. You got red, black, blue, black again, green, black, and orange. And we have a very nice explanation. So I'll just go through it and then you can kind of verify it. There is one way to get to any of the red arrows. There's only one way to get there and only one way to get there. From the first top red arrow, so this one, there are two ways to get to each of the first and second blue arrows. So what are those two ways? Well, from here, obviously that's one way to get to that first blue arrow, but then you can also go like this, which is sort of a, like this, which is sort of a roundabout way of getting to that blue guy. So that takes care of this one and this one. From the second bottom red arrow, which is this one, there are three ways to get to each of the first and second blue arrows. So one way, of course, is this path. Another way is this path right here, going back like that. And then another way is this path right here. So there's three ways. So in total, there's 5 ways to get to each of the blue arrows. So this is very important. Then from each of the first and second blue arrows, so this guy and this guy, there are 4 ways to get to each of the first and second green arrows. So 4 ways to go from here to here. So for example, here's one way. Here is another way, that's 2. And then here is a third way. And here is a fourth way. It's a long way, but it's a fourth way. So that takes care of that. From each of the third and fourth blue arrows, so these guys, there are respectively 8 ways to get to each of the first and second green arrows. So they're saying from here to go to here, or here, 8 ways. And I'll let you do the counting. So that takes care of this. So in total, there's 5, which is up here, plus 4, plus 4, plus 8, plus 8, which is a total of 180 ways to get each of the green arrows, to get to each of the green arrows. So they're counting the 4 up here twice, right? Because you have to get to the first and second, and then the 8 here to get to the first and second green arrows. Okay, so so far we're only just doing these 2. So I guess at the end we're going to double it. And then finally, from each of the first and second green arrows, there are 2 ways to get to that first orange arrow. So obviously this is one way, and this is another way. And then from each of the third and fourth green arrows, these 2 guys, there are 3 ways to get to that first orange. So you take that 120 that you got, and then you multiply it by 2 plus 2, 2 from there for the first and second, and then 3 for the third and fourth. And that's why you got 2, 2, 3, and 3. And that you have to multiply by that 120. And when you do, you get 1200. But that's only talking about the first orange. The second orange one has the exact same pattern. So you have to multiply that 1200 by 2. And that's why you get this number 2400 for the total ways to go from A to B. So I encourage you to go through this once again and just manually figure out all the paths. There's only one big one, and that's this 8 right here. The rest are either 2 or 3, so it's actually not so bad. And another thing I just want to mention is that because in this question one of the factors is 5, the final answer has to be a multiple of 5. Now, if you go back to the original question, the only answer choice that is a multiple of 5 is E. So if you're rushed for time and you only got, say, to here, and you say, well, I know that there's 5 somewhere as a factor of the final number, you can just say, okay, well, of the answer choices, the only one that is a multiple of 5 is 2400. So either way, the answer is E for number 25.